So we're going to use factoring to graph or solve. So here we have a cubic polynomial. We want to graph this, so we're going to graph this using the zeros, so we need to factor this. So first thing I'm going to do is identify what are the possible factors. So my possible factors are going to be plus minus 1, plus minus 2, plus minus 3, plus minus 6. Now I really shouldn't start with 6. I'm probably just going to start with the easiest numbers to substitute. So I'm going to start with 1. So y of 1 is equal to 2 minus 1 minus 13 minus 6. So 1's not going to work. Okay, so that's not equal to 0. We don't really even care what it's equal to. We just want to know if it's equal to 0. So it looks like 1's probably not going to work. So let's try maybe 2. Y of 2 is going to give me 2 cubed times 2 is 16 minus 2 squared minus 26 minus 6. Okay, so that's not equal to 0. So maybe we'll try negative 2. Okay, so we're going to try negative 2. We get negative 16 this time, minus 4, minus, it's going to be plus 26. Okay, so minus 6. Yeah, we get 0 this time. So once we get a 0, we know that this is a factor. It should be x plus 2. So that's going to be x plus 2, and we're missing a quadratic piece here. So I'm going to get that quadratic piece by division. So make sure that when I set up my division with synthetic division, we make sure we put our placeholders in. In this case, we have all the powers, so we don't need any placeholders. I'm going to use plus 2 and subtract. Some people like to use a root negative 2 and add. Okay, that's perfectly fine. But I'm going to subtract. So I'm going to end up with negative 10. So 13 minus negative 10 is negative 3. I get negative 6. If you don't get a remainder of 0, you should really double think what you've done there, because you've made a mistake somewhere, because we don't have factors unless we get remainders of 0. So here we get 2x squared minus 5x minus 3. I still need to factor this. So this is 2x squared minus 5x minus 3. So we need to break that down into its linear factors still. So I'm going to use my little grid here. 2x squared minus 3. I know this diagonal product of negative 6x squared helps me get the split of negative 5. So it's going to be negative 6, positive 1. So here we end up with negative 3, x minus 3. The common factor along here is 2x. The common factor here is 1. So I know that this is going to end up being 2x plus 1 and then x minus 3. Okay, I kind of did this a little bit small, but there it is. Okay, so there's my quadratic factor. Okay, and then from the quadratic factor, I factor this into the 2x plus 1, x minus 3. Okay, and again, make sure that you know how to do that factoring. So the question asks me to graph it. So I need to graph this. So it's a y equals equation. What I do know is I have 3 roots, and my 3 roots are going to be at negative 2. So it's going to be a root here. I'm going to have one at negative 1/2. Okay, so negative 2, negative 1/2. And I have one at positive 3. Okay. I also have a y-intercept, okay, at negative 6. Okay, but really that's the only information I have. There is one more piece that I do have. I do know that the leading coefficient is positive. So I know that it has to trend in this direction. Okay, if it's trending in that direction, then the way I have to draw this is, it's got to go up Okay, it's got to go up like this, through this 0. It's got to come down through that y-intercept, and through there. Now, where you put your vertices, I'm not going to be too concerned with, because we actually can't figure those out. As long as it's in the right trend, as long as you hit those main points, the main points of the zeros, you have to show the positive trend. I may or may not ask for the y-intercept, but you might as well use it because that's an easy coordinate to get. Okay, so there's my graph. That's what we're looking for. So here is a similar question, but now I'm asked to solve this. So although I'm going to do the exact same thing, I'm going to interpret this problem slightly differently because I want the solutions to this equation. Okay, so I'm going to do this exact same way. I'm going to test using my factor theorem, here, my remainder theorem. So I'm going to test plus, minus 1, and 3. So I'm going to say f of 1. Okay, I think we need to use negative 1 here because the positive 1 doesn't look like it's going to work. So negative 1, I get negative 2 plus 10 minus 5 minus 3. Okay, so when I work that out, yeah, I do get a 0. Okay, that means I have a factor, x plus 1. So I'm going to write it out, x plus 1, and I'm just missing the quadratic factor here. Okay, so I'm missing 2 more terms here, which I'm going to get from my quadratic when I do the division. So that's what I'm going to do next. I'm going to divide this out. Okay, so I'm going to use the factor plus 1, and I'm going to subtract. So make sure that I have all my powers here. Okay, I don't need a placeholder. Okay, so make sure that's minus 5 that plus 5 is showing. Okay, so it's going to bring down the first term, multiply, subtract, multiply, subtract, multiply, subtract. And again, if I don't get a remainder of 0, we should be very skeptical of some of the work that we've done. So this ends up being 2x squared plus 8x minus 3. Okay, that's my quadratic factor. I need to still factor that, break that down into 2 linear parts. Okay, so that's what I'm going to do next. Make sure that you know how to factor these. Okay, so 2x squared minus 3. I have negative 6x squared. I need to know how to get to negative 6x squared and add to 8x. Well, that's not possible. So this is not factorable. Okay, we cannot factor this. So we're done. Or are we done? So I'm going to say this is not factorable. Okay, does that mean that there's no zeros though? That's not necessarily true, because I remember solving quadratics that I couldn't factor, and I used the quadratic formula. So here, my factor does give me a solution, x equals negative 3. So there's one solution. This other solution, although it's not factorable, it doesn't mean that there's no solutions. Okay, I can actually put this into the quadratic formula. So I'm going to get x equals negative b plus minus b squared minus 4 times a times c. That's all over 2a. Okay, so this has a solution. Okay, and I can solve it. I get x equals negative 8 plus minus, this is going to end up being, looks like negative 24, so square root 88 all over 4. There is a common factor of 4 in here. Okay, so I'm going to factor that out. So plus minus 2 root 22 all over 4. We should really simplify the common factor, so I get negative 4 plus minus square root 22 over 2. So those are my other 2 solutions. Okay, so I have 3 solutions here. Okay, now it's a little bit hard to graph because this is hard to find the decimal point for this. However, we could do that, but it's not asking us to graph, it's just asking us to solve. I want to know where this is equal to 0. So make sure you understand what you're being asked for. Here we're asked to graph, so we need to draw those zeros onto the graph. Here we're just being asked to solve. And even though we got stuck here with a quadratic, it doesn't mean we can't. We do know how to solve quadratics, so we have to make sure we solve that, even though it's not factorable. Okay, so it does have solutions.